Okay, and now this is 3.1C, and this is where we're going to get into more detail and more descriptive about the domain and range. Okay, so here we go. For the domain, best thing is to scan your pencil left to right and identify the X values in which you are touching the graph. My suggestion is also you can use highlighters and box the graph. My hint here is maybe box the graph with different colors. And I'm going to show you what that looks like. Okay. For the range, scan your pencil top and bottom and identify your Y values in which you are touching the graph. All right, we're going to work some examples here. Grab my highlighters here. Okay, if I'm using just the pencil, okay, note domain and range of these types of graphs are usually written using inequalities or in interval notation. You will see it as both. Okay. All right. If I'm looking at this and I'm thinking about one thing that I can do is, okay, if I'm looking at the X values, well, does it ever stop going this way or this way? The X's never stop because it keeps going in both directions. Since it never stops, there's no place for it to end. This is going to be all real numbers, which we use this fancy symbol for right here. The range is where we get a little bit more detail oriented. Well, if I'm looking at how much is going up or down, well, it's not going any lower than this right here. I don't have any, the graph is not anything below this, and that is located at -2. But I'm going up this way and this way. So I have availability for everything above everything greater than -2. So all Y values greater than or equal to, because it lands on it, greater than or equal to -2. So there's my range is Y is greater than or equal to -2. My domain is all real numbers because the X values never end. All right, next example. Okay, with this one, first I'm looking at the domain. So I'm looking as it going left and right, as I'm looking at left and right. Well, because it's got this arrow, okay, arrows mean never ends. So it's never going to stop going in this direction, and it's never going to stop going in this direction. So it's always going out. So this is, again, all real numbers. Now, if it's going out this way, if it's keep going this way continuously and it never ends, but it's also continuing to go because it's continuing to go this way. So it's actually going in a diagonal, so it's never stopping. It's continuing this way, never stopping. So therefore, my range is also all real numbers because there is never a stopping point where it ends. Like here, it doesn't go anything below. I'll have nothing below this -2. Number 5, this is where it kind of might be helpful to use the different colored highlighters. Okay, for this one, I'm looking at my X values, my X axis. It's going to go from here to here. My graph doesn't go any further. There's no arrows. That's the limits of my graph. So I've got to think, okay, my X value is not going to be anything lower than -1. And it's not going to be anything higher than 1, 2, 3, 4, 5. But it is everything in between. And it's actually equal to it because the graph is on that point. So my inequality for the domain is going to be -1 is less than or equal to X is less than or equal to 5. Now I'm looking at my range, which is my Y values. So I'm looking at the top and the bottom. So I'm thinking about, and I always, when you're doing your inequalities, you do from least to greatest. So always write least to greatest for inequality. So this one here is going to be starting from the lowest. That's 1, 2, 3. So that's a -3. I know I'm talking about Y, so I'm going to put the Y in the middle. And then what's the highest? 1, 2, 3. And it is equal to, because the graph lands on that point, so it's going to be the less than or equal to, because I want everything in between. Okay, next example. Get a little bit faster with these as we go. All right, so again, looking at number 7, because it's got arrows, it's never going to stop going out. It's never going to stop going to the left or the right, so therefore the domain is all real numbers. Where my limits are is how low it goes, because if I look at this, it doesn't go below this line at all, and it doesn't go above this line at all. So therefore, my range is, the lowest it's going to be is 1, 2, 3. -3 is less than or equal to Y, and it's equal to it because it lands on the line, is less than or equal to the highest, which is 1, 2. There's my range. -3 is less than or equal to Y, is less than or equal to 2. Okay, number 9. For my X values, well, it's only at this point right here on the x-axis. It's not going left or right at all. It is located only there. So the domain is x equals 2, because it is only possible to be on the x-axis at 2, which is right there. Now my range is a different story, because it's got arrows. It's going completely up and never ending, and it's going down and never ending. So therefore my range, because it never ends, is all real numbers. Next example. This is where we get into the little specifics, whether something is equal to or not equal to. All right. Again, I like my highlighters because it helps me to know, okay, my limitations. So looking at my x-axis, it goes here. But what I notice is it's equal to right there. And then the graph ends here. But what I notice is it's not equal to. It's an open circle. So now I know my limits. So the lowest it can be is -2, and it's equal to, so it's going to be less than or equal to x, but this is where it throws the curveball. It's not equal to here. So therefore it's just the less than symbol, because it's the x values that are less than, because it's on the left side of 1, 2, 3, 4, 5. So that's a 5, but it's not equal to because it's an open circle. Now we talk about the range. What's the highest it can be? Okay, so this is where the highest is, and this is the lowest. It's hitting the graph at this spot, so therefore it's equal to. So therefore it's a 1 is the highest. Oh, wait a minute. We start from lowest. I got to start from least to greatest. So I'm going to start here, and that's not equal to because it's an open circle. So this is going to be -2, and it's just less than Y. Okay, which is actually, if I read it backwards, this is saying Y is greater than -2, because it's everything that's above -2. So if you flip this around in your brain and think about it and read backwards, this says Y is greater than -2, which is correct. It's all of these Y values that are above right here, but they stop at 1. I can't go any higher than 1, so that's why this is going to be less than or equal to 1. And it's equal to 1 because the graph lands at the 1. It hits at the 1 on the graph. Okay, last one. I'm looking at 13. Well, here's my graph, but so there's an endpoint, but it never stops going to the left. So therefore I can have any number that is less than 2. Any x value that's less than 2, because it's going to the negative side. It's going to the less side. So therefore, my domain is going to be x is less than 2. Now, when I think about my range, I've got to think about, okay, what are my parameters? Well, there's no parameters on the low end, but the high end, it's at 0. So I can have anything that's below 0 on the y value. So anything that's less than 0 on the y value. So this is going to be y is less than 0. And notice I don't have equal to's because it's an open circle. That open circle, I do not have an equal to bar. Okay, that took care of domain and range. Last video will be next, which will be over functions.